According to Charles' law, when pressure in moles of gas are constant, temperature in Kelvin and volume are directly proportional. So if we double the temperature in Kelvin, we'll double the volume. However, this relationship only works with temperature in units of Kelvin. It does not work in units of degrees Celsius or degrees Fahrenheit. We can represent this relationship mathematically using the equation V1 over T1 equals V2 over T2, where T is the temperature in Kelvin and V is the volume. The kinetic molecular theory attempts to explain this relationship. The volume of a gas particle is negligibly small compared to the volume the gas occupies, and the average kinetic energy of a gas scales with temperature in Kelvin. So if we increase the temperature, we increase the average kinetic energy and thus the average speed of the gas particles. Pressure is caused by collisions of the gas particles with a surface. So to keep pressure constant when the particles are moving faster, we must increase the volume. Let's practice using Charles' law. The problem reads, a balloon is inflated to 3 liters at 25 degrees Celsius. What volume will the balloon occupy if it is held in an ice bath until its temperature reaches 0 degrees Celsius? We'll start with the equation V1 over T1 equals V2 over T2. We can rearrange this equation to solve for volume 2, which equals T2 times V1 divided by T1. We need to convert our temperatures from degrees Celsius to Kelvin by adding 273 to each temperature. So T2 is 0 plus 273, and T1 is 25 plus 273. Completing our calculation, we get 2.75 liters. Notice that if we would not have converted from degrees Celsius to Kelvin, our answer would have been 0 liters. We need to remember that temperature must be in Kelvin to use this equation.